Screw gauge is also an instrument used to measure distances or lengths, but it is used to measure very small lengths, much smaller than what a vernier caliper can measure. The commonly available vernier caliper has a least count of 0.1 mm. We had discussed this many times. Screw gauge has a least count of 0.01 mm, 1 by 100th of a millimeter. Okay. How does it work? Screw gauge is based on the principle of a screw. Can any of you tell me what is principle of a screw? Or first tell me what is the difference between a screw and a nail?
Sir, it has threading, sir.
Screw has threading, nails don't have threads, correct. Then what is the principle of a screw?
Like one total, when it rotates by one total rotation, it will shift by one thread, sir.
It will shift by
One thread, like
one thread. Okay, correct, correct. So consider a screw like this. Just a moment. Right. In a properly designed screw, there will be uniform spacing between consecutive threads or successive threads. This distance, the distance between any two successive threads, what is it called?
oh, sir, is it a pitch?
It's called the pitch of the screw. Right. Uh, it will usually be a few millimeters, but it depends on the design. It's not necessary that every screw has the same pitch. Okay. So the principle of a screw is that in one complete rotation, okay, in a single threaded screw, there are multi-threaded screws also. Okay, but that is not part of your syllabus at all. In a screw which has a single thread, the principle is that in one complete rotation of the head, okay, see what happens when you rotate the head of a screw, when the screw is tightened into something. When you rotate the head of a screw clockwise, it gets further tightened, or if you rotate it anti-clockwise, it gets loosened. Okay, so if you rotate it clockwise, it goes in, rotate it anti-clockwise, it comes out. Okay, so the principle is that in one complete rotation, one full rotation, the screw moves forward or backward by a distance of one pitch. Okay, suppose you are drilling this screw into a wall. Fine. When you do one complete rotation, no, one pitch will go into the wall. Two rotations, two pitches will go into the wall, and so on. Okay. Same thing if you rotate anti-clockwise. For one complete rotation, one thread will come out. Two complete rotations, two threads will come out, and so on. Actually, it's just one thread, but when you see from one side, you can call them as separate threads or grooves. Okay. Fine. Now, in one complete rotation, it will move forward or backward by one full pitch. Let's say, for example, let's say one pitch is 1 mm. Okay, that's possible. Commonly available screws, they have a pitch of 1 mm. Okay, so in one full rotation, it will move 1 mm. Then obviously in half rotation, it will move 0.5 mm. Okay, in 1/10 of a rotation, it will move 1/10 of a millimeter, which is 0.1 mm. In 1 by 100th of a rotation, it will move 0.01 mm, 1 by 100th of a millimeter. This is how a screw gauge measures distances as small as 0.01 millimeter. Okay. Basically, the screw head will be divided into 100 equal divisions. Okay. You assume this is the screw head. Just a moment. Okay. When seen from exactly in front, it looks like a circle. So assume it is divided into 100 equal divisions. So this will be 0, 25 here, 50 here, 75 here, and 100. 100 and 0 are the same. So assume it has 100 equal divisions. Then in one full rotation, if it moves one pitch, okay, then in 100 divisions, it will move, or If there are 100 divisions, one rotation is equal to 100 divisions. Sorry. That means each division is 1 by 100th of a rotation. That means for each division of rotation, it moves 1 by 100th of the pitch. Okay. That distance which the screw moves for each division is what you call as the least count of a screw gauge. So how do you calculate how do you calculate the least count of a screw gauge? Least count is the distance moved for a rotation of one division. Okay. Now the basic principle is that one complete rotation makes it move by one pitch. Okay. Suppose in one rotation of the head, there are n divisions. Let's say one rotation is n divisions. So n divisions make it move by one pitch. That means each division makes the screw move by 1/nth of the pitch. Or you can just write it as pitch divided by the number of divisions on the head of the screw. This is the formula for least count of a screw gauge. Okay. Therefore, least count is equal to pitch of the screw, which is usually 1 mm, divided by number of head scale divisions, which means nothing but number of divisions on the head of the screw. Okay. P divided by N. Suppose P is 1 mm and the head is divided into 100 equal divisions, then the least count will be 0.01 mm. In the commonly available screw gauge that you find in stationery shops, this is the least count, 0.01 mm. But again, remember, not every screw gauge will have the same least count. It depends on what is its pitch and how many divisions are there on the head scale. Okay. Now let us understand how a screw gauge is used to measure distances or measure lengths. Okay. Consider this simulation. Basically, this is a screw gauge. There's an object also given here. I'm sure you all must have held and used a screw gauge. If you haven't, this is how it works basically. There's a spindle. Spindle is that rotating part. You can rotate it clockwise, anti-clockwise. And then you can see as we rotate it anti-clockwise, it kind of opens up. Okay. And as it opens up, the space between the stud and the shaft increases. Okay. You can see that in this simulation here. So as we unwind it, that space increases, that gap increases. As we tighten it, okay, tighten it by rotating it clockwise, that gap decreases. Okay. Now, when it is completely tightened, when the spindle is completely tightened, the situation must be like this. What do I mean by it must be like this? Just a moment. When it is completely tightened, there will not be any gap between the stud and the shaft. Okay. When the spindle is completely tightened, this part is what I'm referring to as the stud. This is the shaft, movable shaft. Okay, stud will be fixed. As you unwind the spindle or tighten the spindle, the shaft will move backward and forward. So when it is completely tightened, there will obviously be no gap. That is when it becomes completely tightened. No, that is when the screw stops moving forward. Okay, so there will be no gap here. When there's no gap, what does that mean? It means the length should be 0. Okay, it should be indicated as 0. Now see, a screw gauge has two scales. One is the main scale, this one. It's actually hidden inside the spindle, circular scale. So this is the main scale. In case of a screw gauge, we call it as the pitch scale. Okay. Now you can see markings on it. 0 is visible. And the next division, let's call it 1. Okay, wait, I'll just take another image. You can see the divisions on the main scale or the pitch scale. Fine. 0 is visible. Then this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, and then 10 also you can see. 11th is not visible yet. Okay, fine. So when the spindle is completely tightened, the 0 of the main scale should barely be visible. Okay. The line here, see every division has a line. Okay. 0 has a longer line, 1 has a line, 2 has a line, 3 has a line. Markings will be there. The 0 marking should barely be visible. Okay. That means the pitch scale reading here is 0. Next, there is another scale on the screw gauge called the circular scale. These are basically 100 divisions, 100 or any number, depends on the device, particular device that is given to you. These are basically the number of head scale divisions, HSD, number of head scale divisions. Okay, so the head there is divided into 100 equal divisions. So basically what happens, let us go back to the simulation. In one complete rotation of the head, okay, clockwise rotation or anti-clockwise rotation. In one complete rotation, you can observe the markings there, 0, 5, 10, 15, 20, 25, 30, so on, 50, 70, 80, 90, comes back to 0. Okay, so one complete rotation is equal to 100 divisions. So that scale, that rotating scale is called the circular scale. It's also called the head scale. Fine. When the spindle is completely tightened, means when there is no gap between the stud and the shaft, the 0 of the head scale should be lined up with this reference line. Okay, you can see that on the pitch scale, there is a horizontal reference line. I think it's better visible in this diagram. This yellow line is the reference line. When the spindle is completely tightened, the 0 of the head scale should be lined up with the reference. Like this. Okay, then you can say that this is a properly designed screw gauge. There is no 0 error. See, there's no gap between the stud and the shaft, means the length indicated should be 0. So it will be 0, or you can say it is 0 when the 0 of the main scale is just barely visible and the 0 of the circular scale is lined up with the reference line. So in this case, what happens? Main scale reading or pitch scale reading is 0 and circular scale reading or head scale reading is also 0. When both of them are zeros, the total length indicated is 0. Okay. Now, how do we measure lengths using this instrument? First, you will have to tighten it completely, ensure that there is no 0 error. Okay. How to measure 0 error, I'll explain after this. So let's say it is completely tightened. You can see that the 0 of the, what is that? Pitch scale is barely visible and the 0 of the circular scale, rotating scale is lined up with the reference. So this instrument has no 0 error. Now observe what happens. As we unwind the spindle, as we rotate it anti-clockwise, okay, you just focus on the scales there. As we rotate it anti-clockwise, the division shown by the head scale will increase. Right now, you all look at it and directly tell me, what is the head scale reading now? Which division of the head is lined up with the reference at this moment? Okay, I got answers from 3 of you. The 5th division is lined up. So right now, the head scale reading is 5. Okay. Now, as you unwind it further, see, head scale has 100 divisions, no? When you unwind it by 100 divisions, means when you rotate it by 100 divisions, see what happens on the main scale. Now we have rotated it by 100 divisions. Actually, if I rotate it a little further, you'll be able to visualize. When you rotate by 100 divisions, the 1 on the main scale becomes barely visible. Now I have crossed 1. Okay. But when I had rotated it exactly by 100 divisions, the 1 is just barely visible. In fact, I am also not able to see. If I rotate it any further, that division, that marking will become visible. Fine. So What is this showing us? It is showing us that one complete rotation of the screw, okay, screw or spindle, makes it move by one pitch. From 0, it has gone to 1 on the pitch scale. No, it moved by one pitch. So one rotation makes it move by one pitch. One more rotation if I do, two rotations, it moves by two pitches. The second division on the pitch scale is barely visible now. If I rotate it a little further, you'll be able to see the second division clearly also. Are you all able to see this clearly? Any doubts in this? Okay. So one complete rotation means 100 divisions of rotation makes it move by one pitch. 200 divisions makes it move by two pitches and so on. Fine. Now suppose I want to measure the diameter of the cylinder that is given in this situation. What I have to do is I'll have to unwind the screw first. I'll have to unwind the spindle first till I create a gap enough to fit that cylinder. I fit it there and then I tighten the screw. Okay. Now, as we unwind the spindle, pitch scale readings will show up. Okay, let me take a screenshot of this. We'll discuss this. Right. This is a properly designed screw gauge. There was no zero error. And we can tell the least count also. For least count, you don't actually need that object. Least count is pitch divided by number of head scale divisions. No, pitch is 1 mm here. Number of head scale divisions is 100. So pitch of the, least count of this screw gauge is 0.01 millimeters. We know that. What does this mean? Each division of rotation. Okay, I am not saying complete rotation. Every division of one complete rotation indicates a distance of 0.01 mm. That is what is least count of the screw gauge. Okay, now to fit this cylindrical object, this one, we created a gap there. How did we create the gap? By rotating the spindle anti-clockwise. As we rotated it, see what happened. It crossed the first division, it crossed the second marking, third division marking, it has crossed, fourth division marking also it has crossed. Can any of you tell me what this indicates? Like the 0, 1, 2, 3, 4 on the pitch scale are visible to us. What does that mean? Each pitch scale division was 1 mm. Now 4 is visible, means the diameter that we are trying to measure, let's call it as D, is greater than 4 mm. It has crossed 4, but it has not reached 5 yet. Okay. Therefore, the diameter is 4 millimeters plus some extra distance. This 4 millimeters, which is basically the last division that you see on the main scale, is again called main scale reading, or in case of screw gauge, they call it pitch scale reading. Just like in case of vernier caliper. The last division of the main scale that is visible is called the main scale reading. Okay. In this case, it is 4 mm. So what can we conclude from this? We can conclude that the diameter of this cylinder is some value greater than 4 mm. Now, how much greater than 4 mm? Okay, let's go back to the simulation. Suppose it was exactly 4 mm, the situation would have been like this. The 0 of the circular scale, rotating scale, would have lined up with the reference line. Okay. But when you put the cylinder there, it's actually crossing 4. How much has it crossed the fourth division is what we want. Now to make it go further back, you will have to unwind it. As you unwind it, okay, 5 divisions, 10 divisions, 15 divisions, 20 divisions, 25, 30, 35, 40. As you unwind, it goes further ahead. It goes beyond 4 mm. Okay. How much it goes beyond 4 mm depends on how many rotations you unwind. And okay, let me fit this object back. Right. Now it is completely tightened. And when it is completely tightened, you can see that the 50th division of the circular scale is lined up with the reference line. What does that mean? After crossing 4 mm, it was rotated an extra 50 divisions. Okay. So rotating an extra 50 divisions means, see, for each division of rotation, the screw moves by one least count. Okay, each division of rotation makes it move by one least count. Then 50 divisions make it move by 50 least counts, or n divisions make it move by n least counts. Okay, the division of the pitch scale, the division of the head scale, which coincides with this reference line, is called the head scale division. Sorry, what am I saying? Head scale reading, not head scale division. Divisions are divisions anyway. This is called head scale reading. Whichever division of the head scale coincides with the reference line. Now 50 is coinciding. What does that mean? After crossing 4 mm, 50 divisions were further rotated. So how much is the extra length now? 50 divisions into 0.01 mm. Or basically head scale reading multiplied with the least count. That's all. That is how you get the formula for measuring lengths using a screw gauge. So how do you measure length using a screw gauge? Main scale reading, which is also called pitch scale reading, plus some extra distance. No, extra distance is circular scale reading multiplied with the least count. Or you can say head scale reading multiplied with the least count. Both formulas are the same. Okay. And in fact, there is similarity between the vernier caliper formula and this screw gauge formula. Okay. So did you all understand how a screw gauge works, how to take measurements using this instrument? Any doubts in this? Okay. Let's also quickly discuss zero error, how to calculate zero error and how to make corrections for it. Okay. Consider this example, all of you, just a moment. When do we say an instrument has a zero error? When a zero measurement is indicated as non-zero, we say it has a zero error. Okay. Now see what is happening here. The stud and the shaft are in contact. There's no gap between them. What does that mean? That means the correct length is zero now. Okay. But is the instrument indicating zero? No. The main scale reading is zero. That's fine. The zero is visible on the main scale. So main scale reading is zero, but the head scale reading, you see, the zero of the head scale is not lined up with the reference. Means it is not showing zero measurement. In fact, the zero of the main scale is clearly visible now. Means the spindle has gone further ahead. Means it's showing some positive value. It's showing some positive reading. When it is supposed to show zero reading, it is showing positive reading. Means this instrument has positive zero error. It is showing zero as positive means it will show all measurements as greater values. Okay, like 10 mm will be indicated as something greater than 10 mm. Okay? Because zero is indicated as something positive, 10 will be indicated as 10 plus something. Okay? And you will have to make a correction for it. How do you make correction? When it is supposed to indicate zero, what is the actual length it is indicating? You need to know that. That itself is the zero error. Okay, can one of you tell me how much is the reading indicated by the screw gauge now? I'll give you all 1 minute. Type your answers in chat. Yeah. Had it been a properly designed screw gauge, the zero of the circular scale would have coincided with the reference line. But now that is not the situation. Has the zero gone up or gone down? It has gone down. Zero is somewhere here. Which division is now coinciding with the reference line? 30, 31, 32 is coinciding. Okay. So when the zero is supposed to coincide, 32 is coinciding. So what is the length indicated by this instrument now? The pitch scale reading or the main scale reading is zero because that is the last division that you see here. Fine. Beyond that, how much has it moved? It has been rotated by 32 extra divisions. Now, each division corresponds to one least count. 32 divisions correspond to 32 least counts. So, pitch scale reading plus head scale reading into least count. That's the formula for measuring the length. Pitch scale reading is 0. Head scale reading is 32. Least count is 0.01 mm. Okay, I had mentioned that already. Therefore, it is indicating a length of 0.32 mm when it is supposed to indicate 0. Okay, therefore, the 0 error here is 0.32 mm in this instrument. What does that mean? Every length that you measure with it will be shown greater by 0.32 mm. 0 is being shown as plus 0.32. So suppose you want to measure, suppose the actual length is 10.11. It will be shown as 10.43. Okay. Every measurement will be shown greater than the actual value. So what should you do? You have to make a correction for it. And when the error is positive, correction will be negative. So suppose you measure a length. Okay. Suppose a length is indicated as say 16.45 mm. That's the length indicated by this faulty instrument. Then what is the correct length? How much was the zero error? Plus 0.32 is the zero error. Then how do you correct it? You'll have to subtract 0.32. So the correct length will be 16.45 minus 0.32. That becomes 16.13 mm. That will be the correct length of the object. Okay. So hope it is clear now how to find out zero error, how to make corrections for it. So what all have we discussed? First thing is how to get the least count of a screw gauge. Least count of an instrument depends on the instrument itself. It doesn't depend on what you are trying to measure. It depends on how the instrument is designed, whether it's a vernier caliper or screw gauge. Least count depends on the instrument. In case of screw gauge, how do you get the least count? It depends on, you can calculate it using the principle of a screw. What is the principle of a screw? In one complete rotation, the screw moves forward or backward by one pitch. So if one rotation is divided into n parts, then n divisions make it move by one pitch. Each division makes it move by 1/n of the pitch. So the least count becomes p by n. Get that first. Sometimes they'll give you the least count directly in the problem. Otherwise, they'll tell you what is the pitch and the number of divisions on the head scale. You will have to calculate the least count on your own. After that is done, you can take the measurements. Okay. How do you take measurement? That's all. Rotate the spindle, create a gap, place the object, tighten it. Then based on the divisions that you see on the main scale, you get the main scale reading. Based on the division of the head scale, which coincides with the reference, you get the head scale reading. And how do you calculate the length? Main scale reading plus head scale reading into least count. We discussed the logic behind this also. And if there is any zero error, you'll have to make a correction for it. Okay, fine. Thank you all. Hope you understood the concepts clearly, vernier caliper and screw gauge. If you have any doubts or while solving any problem, you are stuck anywhere, you can send them to me on WhatsApp. I'll respond. Okay, those of you who joined for vernier caliper screw gauge class, you can leave.